Hello everyone. Today we are going to learn about the topic Algebra of Complex Numbers. In this topic we will learn about some basic operations on the complex number like addition, subtraction, how to do multiplication, how to do division, and so on. Okay. So for learning this topic, let's assume a complex number Z1. A complex number Z1 is x1 plus iota y1, and one more complex number Z2. Z2 is x2 plus iota y2. So what is the real part of Z1? Real part of Z1 is x1. The imaginary part of Z1 is y1. The real part of Z2 is x2. And the imaginary part of Z2 is y2. Now, the first operation we will see is addition operation. Is addition operation. If we will add both the complex number Z1 plus Z2. So the result will be when we are adding two complex numbers, then their real part will get added and their imaginary part will get added. Means my answer will be x1 plus x2 will be my real part of the resultant complex number plus y1 plus y2. I multiplied by y1 plus y2. The real part will get added separately and the imaginary part will get added separately. So the resultant complex number will have a real part as x1 plus x2 and the imaginary part as y1 plus y2. Okay. Now next operation we will see subtraction or difference operation. Difference. How to find difference of two complex numbers? So if I do z1 minus z2, z1 minus z2 will do x1 minus x2 means real part will get subtracted with the real part plus iota times y1 minus y2. The imaginary part will get subtracted with the imaginary part. So this is the addition operation. This is how we'll perform addition. This is how we'll perform subtraction or difference. Now next, third operation is multiplication. Suppose we want to multiplication. Suppose I wrote z1 into z2. How to multiply the two complex numbers z1 and z2? For that, first I will write the complex number x1 plus iota y1 and x2 plus iota y2. Here multiplication we will do same as we used to do in the polynomial. When we are multiplying two polynomial, like that only we will multiply here. First, this x1 will multiply with x2, then this x1 will multiply with iota y1. So tell me what I'll get. X1 multiplied by x2 will be x1 into x2 plus x1 into iota y1 will be iota times x1 y2. So the x1 into iota y2 will be iota times x1 y2. Now next we'll multiply excuse me. Next we'll multiply this iota y1. Iota y1 once we get multiplied with x2 and this iota y1 once we get multiplied with iota y2. So when iota y1 get multiplied with x2, so here I will get iota times y1 into x2 plus iota y1 will get multiplied with iota y2. So here I will get iota square y1 into y2. If we will simplify this one, here I will write x1 into x2. And what is iota square? Iota square is minus 1. So here I will get a minus of y1 into y2. This will be my real part of the resultant complex number. Next, from these two terms, take iota common. If I will take iota common, I will get x1 y2 plus y1 x2. This is my imaginary part of the resultant complex number. So this is how we will multiply two complex numbers. Understood? Now next we will see how to divide. Fourth operation, division operation. How to divide two complex numbers. Suppose we want to find z1 divided by z2. So for that z1 I will write in numerator. What is z1? Z1 is x1 plus iota y1. What is z2? Z2 is x2 plus iota y2. So what we will do here? What we will do is we will try to remove this iota from the denominator. remove this iota from the denominator, I will rationalize this complex number. I'll rationalize this complex number. How to rationalize a complex number? We will multiply the numerator and denominator with the conjugate of the denominator. What is the conjugate? Conjugate we will discuss in the upcoming lectures. So for now, you understand that the conjugate of a complex number is nothing but in the complex number only we will change the sign of the imaginary part. So x2 will be x2 only, and the imaginary part is iota y2. So here we are given plus iota y2, so I'll write minus iota y2. This only is the conjugate of this number, this complex number. With this only we will multiply in the numerator and the denominator. So x2 minus iota y2. This will rationalize. Now we will multiply. If you can see here, this is a plus b multiplied by a minus b. So this will come to be a square minus b square, x2 square in denominator minus I square y2 square, a square minus b square. And in numerator, I will get x1 plus iota y1 into x2 minus iota y2. Now next, what is in denominator? Denominator, you will see x2 square is there. What is I square? I square is minus 1. So minus of minus 1 is plus 1. So in denominator, I will get x2 square my plus minus minus plus, right? Minus and minus 1 because of this I square. So minus into minus plus y2 square. And in numerator, what will we get? Numerator will get multiplication of these two. What is the multiplication of these two? x1 into x2 is x1 x2. x1 multiplied by minus iota y2 will be minus iota times x1 y2. Then again iota y1 multiplied by x2. This will be iota times y1 into x2. Next iota y1 into minus iota y2. This will be minus iota square y1 y2. Put it. Any doubt? Now next here I am having x1 x2, which I'll write as it is x1 x2, and here minus of iota square. Minus of iota square is plus 1 because minus here and iota square itself is minus 1. So minus of minus 1 is plus 1. So here I'll get plus of y1 into y2, and from these two terms I'll take iota minus common. Minus of iota common. So this will be x1 y2 minus y1 x2 divided by x2 square plus y2 square. This is how we will divide. This is my resultant complex number. This is how we are going to divide. First we will write the numerator and denominator. If in denominator iota symbol is there, then we will rationalize and we will remove this iota from the denominator. Got it? This is how we will perform the division operation in the complex numbers. Now next, fifth operation is equality. What is the meaning of equality of two complex numbers? If I will say z1 is equals to z2, what is the meaning of this? This means that x1 plus iota y1 is equals to x2 plus iota y2. We will say that two complex numbers are equal if their real parts are also equal and imaginary parts are also equal. That means this implies the real part of z1 is equals to real part of z2, and the imaginary part of z1 is equals to imaginary part of z2. This is the equality of complex numbers. Now next, the sixth property or the sixth point which we see is, if suppose they told z1 is greater than z2. What is the meaning of z1 is greater than z2? What is the meaning of z1 is smaller than z2? See, in complex number there is no meaning of inequality. There is no meaning of inequality. These are meaningless. This you can say is not possible, or you can say has no meaning. This has no meaning. This has no meaning. Why we can't say one complex number is greater than one other complex number, or one complex number is smaller than other complex number? See, earlier also I told that complex number is nothing but a position of a point. a point. Complex number represents a point in the complex plane or Argand plane. Got it? We can't say that point is bigger than another point. Point is a point, right? Point does not have any dimension. We can't say that one point is smaller than another point. Understood? So inequality does not hold any meaning in complex number. We can't say one complex number is greater than another complex number. We can't say one complex number is smaller than another complex number. Equality holds. When two complex numbers are equal, two complex numbers are equal if their real parts are also equal and imaginary parts are also equal. Okay. Now next, the seventh important point. The seventh important point regarding complex numbers. Here we'll see, suppose A and B both are real. A and B both are real. And they are given A square plus B square is equal to 0. Then we might have studied when A and B both are real and A square plus B square is 0. This implies that A is also 0 and B is also 0 because A and B are real numbers. The squares of real numbers can't be negative. So if A square plus B square are two positive numbers, the sum of two positive numbers is 0. That means both numbers itself are 0. Understood? So this we know, right? But in complex number, suppose if A belongs to a complex number and B also belongs to complex numbers, both belongs to complex number. And now if they have given A square plus B square is equal to 0, this does not implies that A is 0 or B is 0. This does not imply that A is 0 and B is 0. Got it? Here A can't be A can be 0, A can't be 0, B can be 0, B can't be 0. Understood? In this complex numbers, this property does not hold. If A and B are real number, then it will hold. But if A and B are complex number, this will not hold. Okay. Now next, the last point. Eighth point. Now, suppose if I write under root of A multiplied by under root of B, this is under root of AB. Got it? Every one of us have studied this property in our lower classes. Got it? It's a very basic property. Got it? But there is a one condition in this property that this property holds when at least one of at least one of A or B is non-negative. Means either A should be non-negative or B should be non-negative. Any one should be non-negative. Got it? Both can be positive, one can be negative, another can be positive, or this one can be positive, this one can be negative. But both can't be negative. If both are negative, A is also negative, B is also negative, this property will not hold. For example, I will explain when it fails. Suppose if I'll say under root of 2 multiplied by under root of 3. This I can write as under root of 6. This is correct. Got it? Because both are positive, both numbers are non-negative, so this property will hold. Now next, if I'll say under root of 2 multiplied by under root of minus 3. This will give under root of minus 6 or root 6 iota. This is also 100% correct. If they are given under root of minus 2 multiplied by under root of minus under root of plus 3. And this is also correct because here I can write under root of minus 2 as under root 2 into iota multiplied by under root 3. This will be under root 6 into iota. Got it? This is also correct. Now next, but when I will write this under root of minus 2 into under root of minus 3, we can't write this as under root of minus 2 multiplied by minus 3. This will give under root of plus 6. Got it? But now if the same thing I will do by this method. Suppose this under root of minus 2 I have written under root of 2 iota multiplied by this under root of minus 3 I have written as root 3 into iota. So now Now you multiply these two. So root 2 into root 3 will be root of 6. Iota into iota will be iota square. So here I will get minus of under root 6. Now tell me this one is correct or this one is correct. This one is wrong. That is what I am trying to explain. This statement, this whatever we did is wrong. We can't apply this property when A and B both are negative. When both are negative, it will give always wrong answer. So this step is wrong. This one is correct. If both are negative, first we convert that into iota, then we will multiply. Okay. Any doubt? We have seen the 8 points here. First we have seen how to do addition. Addition is very simple. Simply add the real parts and the imaginary parts separately. Difference is also say very easy. Subtract the real parts, subtract the imaginary. Multiplication will multiply like this, as here we used to multiply two polynomials. Division will divide two complex number. If there is iota in denominator, then we will rationalize and we will remove the iota from the denominator. And whatever answer we get is our resultant complex numbers. Complex number. Next we have seen equality of complex number. Two complex numbers are equal when their real part is also equal, imaginary part is also equal. Next, there is no meaning of inequality in the complex number. Next, we have seen this property. If AB belongs to the complex numbers and A square plus B square is 0, that does not imply that A is 0 and B is 0. Got it? Now, next, we have seen that this property, which we are learning for these many years, is valid only when either A or B is non-negative. Any one should be non-negative. Okay? Now, next, we'll solve some very important questions related to this topic. So, this is our first question. This very famous question. This type of questions given many times in various exams. Now see, in this question what they said? They said to evaluate the value of this expression. They want the value of this expression. The expression is x power 4 minus 4x cube plus 4x square plus 8x plus 44. And they have given the x value as 3 plus 2i. Now don't keep x value here directly. If you keep x power x value directly, first you have to find x square, then you have to find x cube, then you have to find x power 2. That is a very lengthy method, right? So there is a trick to solve this question. Always out of the given information, whatever value of x they gave, out of this equation, try to make a quadratic equation. I will teach how to make a quadratic equation. First we will make quadratic equation and divide. See how easily this question will be solved. So to make a quadratic equation, what I will do? I will send 3 to that side. So this they have given x is equals to 3 plus 2 iota. This I can write as x minus 3 is equals to 2 iota. Now I will do squaring both sides. So I will get x minus 3 whole square is equals to 2 iota square. Got it? So now expand. So here I will get x square plus 9 minus 6x is equals to 4 iota square. 4 iota square is what? Minus 4. Got it? Next, send this minus 4 to that side. So x square minus 6x plus 13 is equals to 0. 13 is equals to 0. Now, this is a quadratic equation. This is a quadratic equation. The value of x square minus 6x plus 13 is equals to 0. Got it? Now what we will do with this quadratic expression, we are going to divide this complete expression. So now check. You can use long division method also to divide, or you can divide by the method which I am teaching you. See, I want x power 4, right? I want x power 4. So tell me how much we should multiply in this. This one I can write to get x power 4. I'll multiply x square into x power 4. Sorry. I'll multiply this quadratic equation with x square. So what I'll get? X square minus 6x plus 30. Now next, we got x power 4. Then now we'll try to make this minus 4x cube. Now first we'll count how many x cubes are there. So x square multiplied by minus 6x. X square multiplied by minus 6x. This will give minus 6x cube. This will give minus 6x cube. But I want 4x cube. Understood? Minus 6x cube I am getting here, and I want minus 4x cube. So I want plus 2x cube more. If plus 2x cube I will get here, this will make it minus 4x cube. Yes or no? So here I will do plus 2x I will multiply. So here I will get x square minus 6x plus 30. Now see, when I multiply this 2x with this x square, I will get 2x cube. And from here, I got minus 6x cube. Minus 6x cube and 2x cube will give minus 4x cube. Got it? Now we'll try to make this 4x square. Is there any x square term from this? Yes, there is x square term. When this x square will get multiplied with 13, I'll get 13x square. Got it? Any x square term from here? Yes, when this 2x will get multiplied with this minus 6x, we'll get minus 12x square. Got it? Minus 12x square from here, 13x square from here. So in total, I have 1x square, but I want 4x square. Got it? So 3x square more I want. So how to make 3x square from here? I'll multiply this quadratic equation with 3. So x square minus 6x plus 30. Got it? Now see, this got balanced, x power 4 got balanced, minus 4x cube, we made 4x square we made. Now next 8x, we'll try to make 8x. So count all the x terms, will not get any x term, right? Minimum will get x square term from here. Now from here, check how many x terms we are getting. So 2 into 13, 26x we are getting from here. And here what we have? Here we have 3 into 6. 3 into 6 is 18x, minus 18x. Here 26x and here minus 18x. This is automatically giving us 8x. Got it? So it is automatically balanced. Now we'll check for constant term. Here will not get any constant term. Here also will not get any constant term. Only one constant term will get 3 into 13, which is 39. But we want how much? 44. So we have to add 5 here. This is how I divided this complex number without actual division. And this 5 is what remained. We'll solve one more question. Or directly you can use the long division method also to get this. Understood? So here what I'll get? This is 0. This we know that this quadratic equation is 0, right? This quadratic expression is 0. So this will be 0, this will be 0, and this will become 0. So what I will get here? 5 is there. Now, this all term will become 0. So what is our answer? Our answer is 5. 5 is our answer. Got it? I know you have something still in your mind. So for to clear that thing, we'll take one more question of similar thing. Got it? Same method will be used there also to solve that question. Now listen. The given x is equals to 2 plus 5 iota. The given x equals to 2 plus 5 iota. Now we are going to use the same method. We are going to make it quadratic and then we are going to divide it. So here x they have given as 2 plus 5 iota. So I'll send this 2 to that side. So here I'll get x minus 2 is equals to 5 iota. Now I'll do squaring both sides. So here what I'll get? X square plus 4 minus 4 x is equals to 25 I square. 25 I square means minus 25. Got it? Now send this 25 to that side. So here we'll get x square minus 4x plus 29 is equals to 0. Now I'll try to simplify this cubic expression. I'll the cubic expression again. X cube minus 5x square plus 33x minus 90. Got it? Now first we'll try to make this x cube. Tell me how much should I multiply in this to get this x cube? I have to multiply with x. To multiply with x in this quadratic expression, x square minus 4x plus 29. Now next x cube we got. When this cube will get multiplied, we'll get x cube. But now we'll try to balance this 5x square. How many x square we already have? So when we have this x cube get multiplied with this minus 4x, I'll get minus 4x square. But I want 5x square, right? Minus 5x square. So one more minus x square we need. How to get minus x square from here? We'll multiply this complete expression with minus 1. So x square minus 4x plus 29. Got it? This also got balanced. Now this plus 33x. So x multiplied by 29 will give 29x and minus multiplied by this minus 4x will give 4x. So 29x plus 4x is equals to 33x. So this is automatically balanced. Now we'll check for constant term. We'll not get any constant term from here. So we'll check from here. So x minus into 29. Minus 29 is there. But we want minus 19. So what we will do? We will add 10. Any doubt? Now this one is 0, this one is 0. So what is remaining here? The remaining term is 10. So 10 is our answer. Got it? So please solve these questions. These are important questions once again after watching this video lecture. And next question. Next question, they have given x minus 2 plus y minus 3 iota divided by 1 plus iota is equals to 1 minus 4 iota, and they are asking the value of x and y. How will solve this question? If we will see here x minus 2 plus y minus 3 iota divided by 1 plus iota is equals to 1 minus 4 iota. Got it? One method is that we will do rationalization and we will remove iota from the denominator, then we will compare the real parts and the imaginary part. Got it? But this is this is a bit lengthy, right? If we will do rationalization, 1 minus iota multiplying in denominator is easy, but in numerator we will get lengthy, right? So what we will do? Simply I will send this 1 plus iota to that side. So here what I get, we use another method in which I will do cross multiplication. X minus 2 I will keep this side only plus y minus 3 iota, and this 1 plus iota I will send to that side. 1 minus 4 iota multiplied by 1 plus iota. Now multiply this side, I am having x minus 2 plus y minus 3 iota. Now multiply these two. 1 into 1, 1. 1 into iota plus iota minus 4. Iota into 1 is minus 4 iota, and minus 4 iota into iota is minus 4 iota square. Got it? Now next, x minus 2 plus y minus 3 multiplied by iota is equals to 1 plus iota minus 4 iota is minus 3 iota, and minus 4 iota square is equals to plus 4. Got it? Because iota square is minus 1, minus 1 minus 1 is plus 1. So now simplify this one. X minus 2 plus y minus 3 iota is equals to 1 plus 4, 5 minus 3 iota. Now, as these two complex numbers are equal, so their real part will be equal and their imaginary part will be equal. So we compare the real parts. What is the real part of this side? Left hand side is x minus 2. So x minus 2 will be equal to 5 and y minus 3 will be equal to minus 3. From here, what is the value of x? The value of x will be 7. And from here, what is the value of y? Value of y will be 0. These are answers. Got it? Now next question. Now this question, read this question carefully. In a quadratic equation, x square plus p plus iota q into x plus 3 iota is equals to 0. They have given a quadratic equation. They have given this quadratic equation. They have given this quadratic equation. And now they said that p is real, q is real. If the sum of the squares of the roots is 8, sum of the squares of this quadratic equation is, sum of the squares of the roots of this quadratic equation is 8. So let the roots be, let the roots of this equation, roots be alpha and beta. Got it? So they what they have given? They have given alpha square plus beta square value to be 8. Got it? So here alpha square plus beta square, I can apply the formula and I can write this as alpha plus beta whole square minus 2 alpha beta is equals to 8. Got it? Now tell me what is the sum of the roots here? The sum of the roots will be equal to minus b by a. Minus b by a is 1 and b is p plus iq. So minus of p plus iq whole square minus 2 into alpha beta. What is alpha beta? Is equals to c by a. C by a means 3 iota is equals to 8. Got it? Now simplify this one. Here we'll get p plus iota q whole square minus 2 3 is 6 iota is equals to 8. Now expand this one. Here we'll get p square plus I square q square plus 2I PQ minus 6I is equals to 8. Got it. Now next step. Here I square is 1. So here I can write P square minus Q square. From these two terms I can take I common. In this 8 also I'll send to this side. So minus 8. And from these two terms I'll take 2 iota common. So take 2 into iota common. So here we will get PQ minus 3 is equals to 0. Got it. So from here, if this is equals to 0, if any complex number is equals to 0 means the real part is also 0 and imaginary part is also 0. What is the real part? Real part is p square minus q square minus 8 is equals to 0. So from here we got p square minus q square is equals to 8. And next, the imaginary part is 0 means 2 into pq minus 3 is equals to 0. From here we got pq is equals to 3. Now observe these two carefully. P square minus q square is equals to 8 and p into q is 3. Tell me what is the value of p and q. From here you can write the value of p in terms of q or q in terms of p, then you can make a quadratic equation and you can solve. But by common sense also you can tell, right? P square plus q square is equals to 8. P into q is equals to 3. If p into q is equals to 3, tell me what is the possible values of p and q. P and q, the possible values of p and q will be p is 1, q is, sorry, p is 3 and q is 1. Next, or p is minus 3 and q is minus 1. So these are the two pairs of possible values of p and q. Okay. Thank you. Hope you enjoyed the lecture. In next lecture, we'll continue after this. Thank you.